Welcome to Naveen Tech Hub.
All right, let's talk about the invisible engine that powers pretty much every app you use, software architecture. It's the hidden blueprint that decides whether an app can handle a handful of users or a global audience, especially when you start talking about AI. So let's dive into how it all works.
I mean, seriously, have you ever stopped to think about that? The secret isn't just one thing. It's a fundamental decision developers have to make. Do we build one massive do-it-all application, or do we build a whole team of tiny, specialized ones? And trust me, this isn't just a nerdy detail. It's the difference between an app that crumbles under pressure and one that can scale to serve the entire planet.
So to understand where we are now, we have to go back to the beginning. Our story starts with the classic, the traditional way of doing things, the monolithic architecture. And yeah, it's pretty much exactly what it sounds like, one giant solid piece of software.
So what exactly is a monolith? Well, it means everything, and I mean everything, is built into a single, massive code base. You've got user profiles, payment processing, maps, the whole shebang, all tightly interconnected and woven together into one unit. The best way to picture this is to think of a single, big restaurant. The kitchen, the dining area, the cash register, it's all in one big room. If the kitchen gets totally backed up, the entire restaurant slows to a crawl. If you want to upgrade the payment system, you might have to shut the whole place down. Everything is connected, for better or for worse. And here's the trade-off, because starting with a monolith is often way faster and simpler. It helps you get your idea off the ground quickly. But as you grow, that initial simplicity starts to feel like a huge anchor. A tiny little change to one feature means you have to test and redeploy the entire application, and that gets incredibly slow and incredibly risky. And this leads to a moment that pretty much every successful app faces. The monolith, which was your best friend for getting started, suddenly becomes a giant wall blocking your growth. And the name of that wall is scaling.
Okay, scaling is one of those tech buzzwords, but what does it really mean? It's simple. It's about handling more. More users, more data, more traffic, all at the same time, without crashing. When your app suddenly goes viral, can its foundation actually handle that success? That's the core challenge.
Now, there are two main ways to do this. You can scale up, which is like giving your one server a bunch of steroids, more power, more memory, or you can scale out, which is like building a team. Instead of one super strong server, you add more servers to share the load. And that second option, scaling out, is the real secret sauce for building massive, world-class applications.
And this is exactly where the monolith starts to fall apart. You can't really scale out in a smart way. Let's say just your payment feature is getting hammered with traffic. With a monolith, you can't just give more power to the payment part. Nope, you have to make the entire application bigger. The user profiles, the maps, everything. It's just a massive waste of resources.
So, to solve this puzzle, the industry evolved. A new idea took hold. Instead of one giant do-it-all app, what if we built a team of small, independent specialists? And that brings us into the world of microservices. The whole idea is to break that big monolith into tiny, independent pieces. Each service has exactly one job. So you'll have one service that only handles user logins, another that only processes payments, a third that only finds a driver. Each one is a specialist that does its single job really, really well. Let's go back to our analogy. We're not in that one big restaurant anymore. We're in a modern food court. If the taco stall gets a huge line, they can just add more staff and another grill, right? And the pizza place right next to them? They don't even notice. Each stall is its own independent business, totally flexible and able to scale on its own. When you put them side by side, the difference is just night and day. With scaling, a monolith forces you to scale everything. But with microservices, you only scale what you need. That's a huge win for saving money and being efficient. And this flexibility also means teams can update and deploy little pieces of the app independently, letting them move so much faster. And look, this isn't just some theory. We're talking about the biggest names in tech: Uber, Netflix, Amazon. The reason they can operate on such an unbelievable global scale is because they made this shift. Their businesses as we know them today simply couldn't exist without microservices. But of course, this new world isn't perfect. It creates its own challenge. When you break one big app into hundreds of tiny little services, you've just created a new problem. How do you manage all that complexity? How do you keep it from turning into total chaos?
Exactly.
Think about it. When you tap Request Ride on your phone, that single tap might need to talk to 5, 10, maybe even 20 different microservices behind the scenes. Your phone app can't possibly know where all of them are. It needs a single front door to knock on.
And that front door has a name. It's an API gateway. You can think of it as a traffic cop, a bouncer, and a receptionist all rolled into one. It's the single entry point for all requests, and its job is to manage and simplify all the messy stuff happening in the background.
Back in our food court, you don't run around to the taco stall, then the pizza stall, then the drink stall. No way. You go to one central ordering counter, place your whole order, and the staff coordinates getting everything for you. That central counter is the API gateway.
And this gateway is a real workhorse. It does way more than just route traffic. It handles critical jobs like authentication to make sure you are who you say you are, and rate limiting, which stops any one service from getting overloaded. It even caches common responses to make everything feel faster. It's an incredibly powerful tool.
Okay, wow, this diagram looks pretty complex and... well, it is. This is basically a map of the universe for modern system design. But you don't need to know what all these boxes mean. Just focus on what's right there in the middle, the API gateway. It's the central hub that connects and manages all these other concepts, making it an absolutely essential pillar for any big, secure system.
So, we've gone on this whole journey, from the simple monolith to this sophisticated system of microservices and gateways. But what on earth does all of this have to do with the most exciting field in tech today, artificial intelligence?
Well, it turns out this architecture is absolutely essential for AI. First, AI needs massive scale. A recommendation engine handling billions of requests has to scale on its own. Then there's rapid innovation. AI teams can update a machine learning model multiple times a day without touching the rest of the app. It also gives them the flexibility to use the best programming language for each specific AI job. And critically, it builds in resilience. If one AI feature fails, it doesn't take the entire application down with it. That is a game changer.
So when it comes down to it, this microservices approach isn't just a trend. It is the foundation. It provides the flexible, scalable, and resilient platform required to build the complex, data-hungry, and constantly evolving AI systems that are literally changing our world. And that leaves us with one final thought. The architectural choices that developers make today directly define what's possible tomorrow. As AI becomes a part of everything, the question for every app out there isn't just, does it work now, but is its foundation strong enough to